So, welcome to Phymaths podcast. Today, our guest is Dr. Daniel Whiteson. He has been on the podcast before. He's an experimental physicist at UC Irvine and he is a science communicator. He has written books like We Have No Idea, Frequently Asked Questions About the Universe, and he has an upcoming book called Do Aliens Speak Physics, right?
That's
Yeah, that's
right.
the book. Right. So, Dr. Whiteson, welcome to the podcast. Nice to have you again.
Thank you very much for having me on. Please call me Daniel.
Sure. So, this book that you have written, Do Aliens Speak Physics? What was the major, motivation to write this book? What were the questions that you had in mind before you wrote this book?
hmm Well, I've always fantasized about meeting aliens. I mean, we work so hard and so long to figure out the secrets of the universe. And, we've been making progress, though it's slower than anyone would like. And it just feels to me tantalizing to imagine that there could be aliens out there that have been working on physics for a million years, a billion years. What have they learned? And if they could just like show up and tell us the answers, like, wow, that would be extraordinary. Imagine, leaping forward a million or a billion years into our scientific future. It's exciting. And it's also a little bit flattering. It's imagining that we are on some journey that's shared with other intelligent races, that we're on the right track, and that we have something in common with all those folks. And anytime there's a concept, an idea that makes you feel good about yourself and that you really want to believe, I think it deserves a little bit of extra scrutiny, a little bit of extra skepticism. As a species, we have a history of like putting ourselves in the center of everything and just sort of like believing that for a while until the data shows us the otherwise. And so I wanted to understand how likely it was that if aliens show up, we really could talk to them about physics and about science, or explore the other idea, the idea that maybe when aliens show up, they'll be much more alien than we expect. Essentially, the book is asking, is what we've learned a function of the universe that anybody would discover, or does it reflect something about ourselves, the way we like to think, the stories we tell, the way we see the universe? So in the end, it's a deep philosophical question, but I wanted to phrase it in terms of this sort of immediate, concrete alien example because, hey, it's more fun to think about aliens. And also
Right.
because I think that will really happen someday, and I think we should be prepared for it.
Right. I mean, there are many questions that you can ask about when you go into this kind of, direction. Well, I mean, one aspect that I want to discuss is that so I think we will need a new word for it because when we are talking about like politics on Earth, we use the word geopolitics, right? So that if you have a country who has like advanced knowledge of something and they think that okay, if this knowledge is also acquired by some other country, they may become more powerful, though
Mm.
sometimes they don't want the other countries to get that knowledge. But do you think that that can happen, that okay, that aliens have some knowledge of physics and they don't want human beings to get that knowledge? So it may so there is, I don't know if they have seen this, if you have seen this short movie on YouTube. It's something like that. There is this girl who is discussing about all the possibilities regarding aliens, and she's just talking to this guy whose face we never see, and at the end of the day it turns out that this guy was an alien who disguised as a human being. And what he does is that after listening to everything she said, he just wipes her memory and just goes away. So what if aliens are like, you know, what I'm trying to say is that what if aliens are like deterring us from getting the, forbidden knowledge of physics? I mean, that's an interesting possibility to consider.
Yeah, maybe aliens are the reasons we haven't made string theory work yet.
Yes,
No, it's a
exactly.
fascinating question, and we should be prepared for any kind of aliens. We should think very broadly about what first contact would be like. And I think in that particular scenario, I'm sure that there would be some aliens who think, hey, let's not share quantum gravity with the humans or whatever they're doing. But I'm sure that there are factions. Aliens are not going to be monolithic. There are going to be some who think, let's collaborate with the humans. It'd be cute to see what they could do with our science. Or maybe even humans have developed something unique. Maybe there's some branch of mathematics we've been working on that could be useful to them, right? And so I'm sure there'll be some folks eager to share and some folks who want to keep the secrets from us. And, we
Yeah.
just have to hope that they fracture.
Yeah, yeah.
But yeah, and that would be so frustrating. But, even more frustrating to me is another scenario where the aliens show up. They want to share the secrets of the universe. They patiently teach them to us, and we just can't get it. There's no
Mm,
guarantee that the human brain is capable of understanding the universe. So far, folks like you have been making great progress, and we have the capacity to unravel the nature of the universe, but we don't know a fraction of the mystery we've solved. We don't know that we have the capacity. Certainly, other creatures on Earth, dogs and dolphins, whatever, have limited capacity to understand. So we must also have some limit to our ability to understand the universe, or maybe not. And so it could be that they show up and we just can't figure it out, man. And that to me would be even more tragic.
right. So one chapter of the book that you have, I mean, don't want to give spoilers, but just one chapter's name, if that's okay. So
Hmm.
one chapter that you have in your book is called "Is One Plus One Equals Two Everywhere?" Right.
Hmm.
So what are the reasons why you think that it may not be the case everywhere? I mean,
Yeah.
there is this 360-page proof by Russell and Whitehead that one plus one equals two, right? So probably it will
Yes,
be
a
true.
result which is frequently useful, they say.
Yes.
Yes. No, it's one of the most important questions, right? If we're going to ask whether our project, the project of modern physics, is universal or human or cultural or earth-centric, then one of the greatest arguments we have is that we're doing it mathematically and that mathematics seems to be the language of the universe. I mean, I remember having this experience seeing quantum mechanics and seeing the calculations predict experiments out to 10, 11 digits and thinking, oh my gosh, this is the source code of the universe, right? And there are these moments in history where math has led physics to discoveries. You have Maxwell seeing a gap in the symmetry of the equations and saying, oh, maybe there's another piece here, and then going out and discovering it, right? It's real. There's Higgs seeing the broken symmetry and hypothesizing a piece that explains everything. And, the mathematics have led us to discoveries. And so it's easy to convince yourself that math is a language of the universe itself, not just the way we think. But there are also deep questions there. There are questions about whether math is very useful or actually necessary, right? It's certainly very useful, but it's not clear that it's required. And there's a really amazing book written by Hartree Field called Science Without Numbers, where he attempts to build a theory of physics, gravity specifically, without using any numbers at all. He makes the argument that math is a fiction. It's not that it's invented in the sense that it's like arbitrary, but it's like a game with specific rules that are useful for us to do our calculation. And I think the best way to think about his approach is to imagine that we use math as a sort of way to save intermediate steps in our calculation. And the most concrete example of that is like a field. When you want to calculate how the Earth moves around the solar system, you can just use forces, or you can imagine a gravitational field, and you could use that to then calculate the forces. And we think of fields as real, right? You do quantum field theory, you think about those fields out there in space. But there's no evidence that fields are real in a philosophical sense. We can't see them directly, right? We interact with the particles or with the masses that are moved by the field. We see the effect of fields on other things. We don't see the fields directly.
What,
And
what about the Casimir effect?
yeah, what about the Casimir effect? Um, I've read some interesting papers about the Casimir effect. The Casimir effect, you have two plates and they're drawn together. This is sometimes seen as an argument for the existence of the quantum vacuum and real energy there. But you can also calculate the Casimir effect just as a time retarded van der Waals effect. You don't need the quantum vacuum to get the Casimir effect. So I think there's a philosophical debate about whether
Mhm.
the Casimir effect proves the existence of the fields. And anyway, you're not seeing the field still, you're seeing the force on these two plates. And so you could argue that the fields are a calculational tool you're using to get these results. You don't know that they're real, that they're there when you're not looking, essentially. Um, and so Field makes this argument that all of math is like that. And he sets up a theory of gravity without any numbers in it. He says numbers are a way for us to organize our thoughts, but there's sort of this symbolic fiction that we've created this number line to attach things to when you don't need it. Like he shows that to do the calculations you need for gravity, you need only relative things. Like this is more mass than that. This is a greater distance than that. So you still have quantities, but you don't associate them with the number line because the number line is this sort of intermediate fiction you don't really need. And he goes on from that to argue, like, hey, maybe you don't need numbers to do science at all. You can think about the universe, you can make predictions, you can even have a theory of gravity without numbers. And it's not a great theory, right? It's
Right,
hard
of course.
and it's
I mean, what
ugly.
would the prediction look like if you are not using numbers? What would the prediction look like? I mean, have you seen and some predictions that he talks about?
Yeah, and you can read his book, Science
Mhm.
Without Numbers by Hartree Field. It's dense. It's not for the lay reader for sure. But again, the predictions are not numerical, right? It's not like he says, "I predict the Earth will move at this velocity in this number." It's like this distance will be greater than that distance, and uh, and this
Okay.
velocity will be greater than that velocity. So it's awkward, right? It's not
Right.
intuitive. It doesn't feel good. It's just done as an exercise to make the point that maybe math is super duper useful, and maybe that's because of the way we think about the universe, but maybe it's not absolutely necessary. Um, and if you do a dive into like, well, where does math come from? Like, where do these rules of math come from anyway? You refer to the famous proof 1 + 1 = 2. That still begins from some axioms, right? Peano's axioms of arithmetic, which we think underlie all of mathematics. Where do those axioms come from? Why those axioms and not some other axioms, right? Are we required to begin from those? And that's not a question that philosophers of math yet know the answer to. They still debate it. And so, if we don't know where the rules at the heart of math come from, how can we argue that every intelligent species around the galaxy has to begin from the same ones and it has to end up at
Mhm.
the same place?
Right. So, I think to derive 1 + 1 = 2 in the book by Russell and Whitehead, they just use logic, and you can. So, what you're trying to say is that even the rules of logic, for example, the Aristotelian rules for logic,
Hmm.
they are debated, and that's true. I mean, for example, there are these mathematicians who think that the law of excluded middle, which means that some statement is either true or not. That's it. There can't be a third possibility where it's neither true nor false. That is not correct. I mean, some mathematicians think that, but this law, or the law of excluded middle, is one of the laws of Aristotelian logic. So that is that what you mean? What you when you're saying that there is this debate about the axioms of logic itself?
Yeah, I think you could also frame it in terms of set theory, right? You can use set
Hmm.
theory to as the foundation of all of it. But a lot of this assumes some concepts like integers, right? We think naturally about counting. It seems obvious that like any intelligent species is going to count. I'm me, you're you, together we're two people, right? It's very easy and it doesn't feel like there's a lot of assumptions, but there are some assumptions there. And when we're thinking broadly about how other intelligent races might confront the universe, we have to question all of them. And one assumption there is that there's like a distinction between that we have some things in common and some things that are separate. Like I am not you. There's a distinction between our bodies. My body ends somewhere and yours begins somewhere. But we have some things in common. So we group ourselves together into a set. We're physicists, we're people, right? We're humans. And those things are cultural. Like, how do I decide where my body ends? Why do I call myself one? This whole concept of an integer,
Mhm.
a whole number, right? What if we were creatures that evolved in the atmosphere of a star and we were made of plasma and the edges of our body were much more fluid and maybe people even joined together and merged? I mean, you can get crazy with the speculative fiction, but it's not that hard to imagine an intelligent species where the concept of an integer might not be so natural, right? Or the concept of adding integers together, grouping them in a set might also not be natural. Like I look at an apple and another apple, and it's very natural for me to say, okay, this is two apples, right? But they're also different, right? I'm deciding that they have enough in common for me to put them together into a group. Somebody else could say, well, one's red and one's green, so there's no way you should put those together into a set. It's basically a different kind of fruit, you know? And so these things are cultural. There's a lot of things that we find intuitive because of our culture that aliens just might not. And, you know, I'm not saying that aliens are unlikely to do math. I'd be shocked if they didn't. But it would also be amazing and an incredible opportunity to learn about other ways to explore the universe. So, one reason I wrote this book is to like try to steelman the other point of view, to say, you know, what's the weirdest aliens could be? How can we prepare for aliens to be strange in some way that's very, very counterintuitive? Because also, I think it's super fun to dig into the foundations of these questions.
Right. I mean, but don't you think that, for example, we have come up with very strange number systems like quaternions and octonions, although we never encounter them in our real life. We have,
Hmm.
stumbled upon them just because of pure thought. So,
Yeah.
for example, if you talk about like integers, now when people do a real analysis, the integers are a result of a set of axioms. So even
Hmm.
if aliens don't see integers, in their lives, if they are just clever enough to come up with those axioms, then they may know what integers are,
Yeah,
right?
absolutely. It's certainly possible that aliens, even if integers aren't intuitive to them, that they've come up with the
Mm.
concepts and they've built that mathematics. But it seems to me like it's also a possibility that they've explored other directions that we haven't.
Mhm.
That they do something you might call mathematics, but they start from a different point of view, a different set of axioms, and they use them in a different way. And maybe you find an even more natural way to express the universe, to explain and describe it. Like you know how powerful it is to have a new mathematical formalism or even just a new notation, right? Allows
Mm.
you to explore the universe and come up with new explanations and see connections, right? Just trivial things like, you know, Einstein's summation index or, you know, the way we write down the Lagrangian to know whether it's Lorentz invariant really are helpful in coming up with theories. And so these mathematical structures and boundaries, I think they really do shape the way we explore the universe. And if we had different ones, we could end up with different theories, different descriptions of the universe. And I kind of hope that aliens have, because we would learn a lot if they
Right.
show up and they're like, "Wow, y'all are definitely on the wrong track."
Well, when you said that they may have different notation, I think that has this inbuilt assumption that the aliens write.
Hmm.
Right? Do they write? Do they have hands to write?
Yeah,
I mean, what if
absolutely.
they don't
Right.
write at all? Right?
Yeah,
I mean,
exactly.
it's hard to imagine that how would they do physics or maths if they can't write. I can't see any other way. I mean, if they have very good imagination, for example, but then the question is that how do they communicate that imagination to other
Yeah.
aliens? I mean, we don't know any mechanism by which you can do it. So if they don't write, that'll be an interesting thing to see. That okay, how can you do that if you don't
Well,
write?
I think it's really insightful that you say that because I've noticed that theoretical physicists in particular use that word right in a special way. You know, the general public, they know what writing is and you can write things down. But physicists, theoretical physicists in particular, say, like, I can write down a Lagrangian that blah, 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 or I can write
Mhm.
this down as a way to express, like, this makes sense mathematically, or I can construct this idea.
Right.
And for you in particular, there's this connection between having a mathematical concept and being able to write it on the page. Yeah, I think that
Mhm.
really shows something about the culture of theoretical physics. And you're right, aliens might not use writing, you know, but if they have discrete bodies and they communicate between each other, it seems reasonable that they have to use some sort of symbolic communication system. And, I read a lot of papers about understanding symbols, and hadn't realized before I wrote this book how arbitrary our symbolic system is. We have these thoughts that exist in our head. You have to communicate them to another human. And they go through this medium of like either writing on a piece of paper or speaking or dance or whatever. But that medium is arbitrary. Like we attach that meaning to those symbols, but the symbols themselves
Mhm.
don't have any inherent meaning. And sometimes they feel intuitive to us because they're so familiar, but that familiarity is cultural. And it struck me when I was reading about, the history of decoding even human symbols. Like we have
Mhm.
kind of a checkered record of decoding human signals. Like the folks at SETI are doing great work and they're listening for messages. But personally, I think it's almost impossible if they get a message, even if they're lucky enough to find one and to recognize it as alien, for them to decode it into something that makes sense. I think it may be impossible. And so, like, the history of our decoding our own languages is not great. We struggled with Egyptian hieroglyphics. There are existing human languages that we have lots of examples of that we have not decoded because there are no, living speakers or writers left, and they're too far distant from us culturally for us to understand them. So I think that a lot of people underestimate the difficulty of translating alien symbols. Even if we got like the equivalent of their pioneer plaque, I think we would be scratching our heads for a long time, maybe forever.
Right. I mean, that raises the question that do you think that aliens will be able to understand what's on the Voyager 1 or Voyager 2, sorry,
Yeah.
right? On the golden record. I
Yeah.
mean,
Well,
I
I
don't
did a
know.
little experiment here. For those who don't know, the Golden Record, the Pioneer Plaque was put together by Carl Sagan and his wife and Frank Drake, I believe. And it's a way to sort of say like, hey, here's where we are and here's how we think about the universe. And it has these little depictions of the hydrogen atom and spin and the flip. And it uses the spin flip time to indicate like a unit of time. And it's clever, right? It avoids our mathematics. It avoids English. It's sort of symbolic in this creative way that I think was supposed to be like, I think it was supposed to mean like, hey, if you're aliens and you think about physics, you probably would recognize these things. But boy, there's a lot of culture in there, The
Mhm.
depiction of the hydrogen atom, it's a little orbit around the nucleus. And like, we don't think about hydrogen that
Yeah.
way.
Yeah.
We did
It's like
for
a kid's
like
story.
yeah. Well, and we thought about it that way for like maybe 20 years, like the Bohr atom, and then we quickly realized, oops, yeah, it's not like that at all. It's, probability cloud. So I did a little experiment. The Pioneer plaque is old enough that a lot of grad students here at UCI had never seen it. So I sat them in a room and I said, "We got this message from aliens. What do you think it means?" And after an hour, they were nowhere near the right answer. And like, of course, if we actually got that from aliens, we'd spend more than an hour of UCI grad student time. But the point is like, it's not obvious, right? We think it's obvious. It was intended to be so clear and so basic and so easy to decode that even aliens could figure it out without our cultural commonality. But even humans, with all the cultural commonality, struggle with it.
Yeah.
So I think we often underestimate how difficult it would be. So that's why in the book I focused on the scenario, not that we get an alien message and we're communicating over space and time, but that they're here. Because if they show up, then we have a chance. We can point at an apple and say apple, and they can repeat it and we can figure it out, or they can, issue their smells or do their dance or however they communicate. We have a chance if we have cultural context, like physical context together, to maybe build some method of communication and then get to start to ask interesting questions about, space and time and wormholes.
Right, right, right. I mean, as you mentioned that we do struggle sometimes when decoding, languages of human cultures, let
Hmm.
alone aliens.
Hmm.
Have you come across? So you said that you read the history of, decoding, languages. So did you come across like Voynich record?
Yes, the Voynich manuscript, you mean?
Yeah, one-inch manuscript,
Yeah.
or one. Some people call it record for some reason. I
Yeah,
don't know. So
absolutely.
that's something that's still unsolved. But some
Hmm.
people think that okay, probably it's nothing because the person Voynich may have fabricated itself. So that's something that we haven't understood. And then there are other examples like I think it's outside the CIA building called the Cryptos,
Yes, that's right.
right? So I think the fourth part of it is still unsolved, but the
Hmm.
first three parts took a long time to be solved, although
Hmm.
it's in English, but it's like a code.
Mm.
So when it comes to like human communication, even there we do struggle a lot. So
Yeah.
it's not, surprising that we will. Okay, one question that I have, I like to discuss is that do you think that aliens will have like distinctions between physics, chemistry, and biology?
Oh, wow. I love that question. I doubt it. I feel like those distinctions are so cultural.
Hmm.
The way we separate, like experimental and theoretical physics or solid state and particle physics, there are obvious connections between fields.
Hmm.
And we draw these distinctions, these are historical. They've sort of come up out of the way that we've made discoveries, the order of events, the people who influenced the field, the way we named it. I think that's 99.99% cultural. I mean, I think there is a spectrum of ways to think about the universe, but I think the way we draw those dividing lines is almost certainly cultural. And even as you zoom in further, like I feel like there could be some cultural influence, some human bias in the way that we decide to zoom in on the universe and divide up the regime even further. Like particle physics, we think about these microscopic entities. Planetary physicists, they zoom out and they think about rocks. The universe itself is like it's like a huge spectrum of phenomena, and we draw these dotted lines around certain ones of it that we decide we're interested in and we want to understand. And something sort of amazing and beautiful happens, which philosophically I think is still not fully understood, which is that out of the crazy, chaotic, buzzing complexity of the universe, these simple stories emerge. Like you can write down theories of particle physics and predict what's going to happen to the Large Hadron Collider, but you don't know the underlying truth. We don't have quantum gravity. It's sort of a mystery that effective theories, as we call them in physics, work at all, that we can bundle up all the UV details into a couple of parameters and say, well, we don't know and we don't need to know. We can measure those and move on. And that principle underlies the existence of the field chemistry and biology and economics and politics, right? Where they don't understand the underlevel details, but still they can do science. These simple stories emerge. And to me, it's wonderful that they do, but I wonder also how much bias there is. Like, do aliens look at solar systems and say, yeah, planets are the most important thing, let's understand that? Do aliens look at microscopic interactions and think about particles in the same way that we do? Or do they draw different dotted lines around this massively complicated phenomena that is the universe?
Right. But even if they don't have like chemistry physics distinction, one thing that kind of seems inevitable is that they do distinguish between living things and non-living things. I mean,
Hmm.
it would be surprising if they don't, and they may have something like biology if
Hmm.
they do distinguish between living things and non-living things. So
Hmm.
don't you think that this is going to be the case?
I think it's likely, but again, you are putting your finger on something that's important to us.
Mhm.
We consider ourselves and our experience and the fact that we are alive important, but like if you dig down into it, biologists don't even have a great definition for what is alive and what is not,
True.
right? And it's one of these things where, like, well, look, we're important, so let's come back later and retrofit the definition so that it makes sense, right? We keep like adding caveats so that we are centered in it, so that we are something special. Because what we see is that there's a whole spectrum between life and non-life. The distinction between it is a dotted line we're drawing, and the universe has a continuous spectrum of behavior. We find ourselves important, so we want to draw that line, and so we come up with these like Baroque descriptions. It's like epicycles, right? I think we may eventually have to give that up and say, like, look, there's things that are more like us and things that are less like us, but there's a whole spectrum of stuff out there. Um, but I don't know.
I see. Right. Um, you know, I'm pretty sure that you are familiar with these kind of, I will still call them conspiracy theories. So there are these conspiracy theories that,
Yeah.
a lot of geniuses in the past were actually communicating with aliens and they were guided by aliens to come up with the stuff that they came up with. Now, the thing is that, okay, this is not non-falsifiable. I mean, it's sorry, it is falsifiable. That's what I'm trying to say. So if there are aliens in this world, I mean, if we suppose that we find out that there are aliens, right? I don't know how to, uh, you know, falsify these kind of claims because these claims, of course, they do look like, out there. I mean, if I'm being very polite, uh, do you know how to argue against these kind of claims? Because of course, you and I don't think that there are no aliens. That will be very, very, surprising if there are no aliens in this universe. But how to like, argue against these kind of claims that if there are aliens, why would they communicate with only a certain, certain number of individuals and not all of the human race? So, do you have any thoughts on that?
It's a interesting idea. It reminds me a lot of the ancient aliens stuff. You know, you
Yeah.
look back at the accomplishments of ancient civilizations and you can't quite give them credit for it. So you're like, well, let's, invent aliens because, hey, it's a cool idea. And I think we should be skeptical of cool ideas, something that sounds appealing, that, hits a lot of the Jerry Bruckheimer buttons or whatever, that deserves extra scrutiny. And so this
Hmm.
idea that like maybe Einstein, was influenced by aliens. Yeah, maybe, but you can also dig pretty deeply into Einstein's work and understand where those ideas came from. Like you could tell, no, he got stuck and then he talked to mathematicians and they showed him how geometry works. And that's where the insight came from. And those guys have been working on that independently for decades. And so like the story you need to involve aliens there becomes more and more baroque. It's like, well, maybe aliens influence those mathematicians and they got Riemann to work on manifolds and like they're orchestrating everything behind the scenes. I'm like, yeah,
Right.
but then, the simpler explanation is just that there are some smart people and they worked on stuff and they figured it out. And so
Right.
that explanation, I think, requires a lot more evidence, specifically of aliens influencing it, because we have a pretty good story that doesn't require it. It's not like it was, Newton took some weird drug and had a moment of epiphany, and nobody really understands where this idea came from. The story is not like that. It doesn't require some external explanation. As awesome as that would be, right? And I feel this tension in science communication between needing to be appropriately skeptical because we want to treat these questions seriously. We don't want to jump on every interstellar comet and claim that it's aliens, right? We want to be responsible, but also sharing our enthusiasm for the idea. Like,
Mhm.
wow, we'd love it if it were aliens. I would love if this new interstellar comet was an alien visitor. I would love if aliens participated in our science conferences. Like, come on down, dudes, talk to us about quantum gravity, right? We don't want to just be negative, being like, no, it's not aliens. But it's awkward, right? You're often put in that corner, having to be the adult in the room, being like, well, there's no actual evidence for that, and let's be reasonable about it. It's a
Right. I mean,
difficult line to walk.
if we do take this claim seriously, I mean, the consequences of this claim seem to be, at odds with reality. For example, you said that what if aliens got Riemann to work on like Riemannian geometry, and they knew that Einstein is gonna come, and then they told Einstein what GR is. Now the thing is that Riemann. A lot of people don't know this, but Riemann himself came with the idea of curved space. Now he didn't say curved space time, but he did think that gravity is curved space.
Hmm.
Now, how to square that with the alien thing? For example, you can say that okay, aliens told Riemann that it's curved space, but that's not true. Why would they tell Riemann that it's curved space? I mean, there's no reason to do that. If they didn't tell Riemann, then he came up with it himself, which means that humans can come up with such an idea, right? And then it doesn't make the Einstein idea very, very out there, because if Riemann can come up with it, then it means that humans can come up with it. But then there are other things. For example, if aliens told Einstein that GR is the way to go, then why? So in 1912, actually, Einstein wrote down a wrong field equation, but then
Yeah.
he didn't publish it. So why was that happening? I mean, why would he write down the wrong field equation if aliens were guiding him? So these kind of things are like, you know, as far as I understand, I think they're at conflict with this idea that aliens were guiding anyone. Uh,
Totally.
Right. So, but one thing that I want to discuss here is that if suppose that if aliens were doing it, so suppose
Mhm.
okay, let's take an analogy. Suppose that human beings, are supervising another species, and that species doesn't know that human beings are
Mm.
like supervising them, and we are teaching them physics, right? But we do understand that as their brains will evolve, they will be able to take more and more complicated physics. So we don't teach them everything all at once, right? We just somehow teach them something and then wait,
Right.
right?
We're the aliens in this scenario. Love it. Yeah.
Right, right. But I think that's one possibility that is kind of understandable. So
Hmm.
someone may say that, okay, aliens are doing this to us.
Mm.
And sometimes they, make us make mistakes so that people are not suspicious that, okay, this is too good to be true. So what do you think about that possibility?
I mean, it's possible, right? But these ideas just have to get more and more elaborate to explain all of these details, right? Like, as you say, the story doesn't make sense. Okay, well, then let's say the aliens made the story not make sense to make it more realistic, and the theory becomes more and more elaborate without any more data, right? Without any more confirmation. It just gets more elaborate to fit the data. And so that's the kind of thing you see when you've decided on a preconceived narrative and you want to use it to explain the universe instead of letting the data tell you what happens, right? And so I think if you look for the simplest explanation that describes the data, then you just don't need aliens. Um, to explain the progress of physics. But I do think it's really fun to look back at the history of physics and to see these moments, like when somebody had an idea or somebody talked to somebody else and together they made some progress, because it makes me wonder about how it might have gone differently. You know, imagine not just aliens, but like say you had 1,000 Earths with humans on them and then we all got to meet at a science conference today. Where would the other Earths be? Would they have figured out quantum gravity? Would they be on a completely different track? Would everybody have made discoveries in the same order? Is our particular science, would we have physics and chemistry and biology? We don't even know the answer to that question, not to mention like if they're aliens with different minds and different ways to see the universe and think about it and different kinds of mathematics. Even just alternative Earths is a fascinating question because the history of science is filled with like these random moments when somebody realized something or had coffee with somebody. And I mean, my particular individual career has been so controlled by like, I went to this conference, I saw this talk, I had this idea, then I spent 3 years working on that, right? The whole history of science is that way. And so, there's a real possibility aliens show up and they're very, very similar to us biologically and ideologically and conceptually, but still they have a very different history of discovery. And the
Mhm.
things they struggled with are different because they figured out stuff in a different order. It could be vastly different, or it could be quite similar.
Right. I mean, if somebody didn't actually know, well, okay, if somebody is familiar with the laws of physics very well
Hmm.
in a human being, but that person is not very well versed in the history of physics, and if you ask that person, okay, make a guess of the order in which things were discovered, I'm pretty sure that that logical order doesn't square up at all with the actual order. For example, it's fascinating to me that like quantum mechanics and Dirac equation were discovered before neutron. I mean,
Mm.
how? I mean, neutron is something that we learn about in school, right?
Yeah,
Quantum mechanics is something that we learn about in university. So how were they discovered before neutron, for example? And the fact that chemists were convinced of the existence of atoms before physicists. I mean, physicists didn't even believe in atoms until
right.
a lot of physicists until the early 20th century. So that doesn't seem right. And I'm pretty sure that if there was another Earth out there, things would be very different there.
I mean, it's also fun to imagine even further back,
Mhm.
like,
Mhm.
there are independent ways that humans have started down this path to understanding the universe. The
Mhm.
Chinese, the Mayans, the Sumerians, there's commonalities there, but there's also differences, the number system they used, obviously, but also just the way they thought about the universe. Like the Sumerians and then later the Greeks, obviously very geometrical. And that sort
Right.
of influence the way we think about the universe. Like if you think about, how does the solar system work? You imagine a geometrical picture where things are moving, and the answers to questions are where they are in that space. But it didn't have to be. Like we know that geometry and algebra are very, very closely connected, right?
Right.
And the Chinese, it turns out, didn't think as geometrically. Their mathematics was much more algebraic, and so they could have gone down a very different path. Later on, of course, the world collapses because of transportation and colonialism into a smaller number of independent scientific threads. But it's fun to imagine, like, what would the Mayans be working on right now if they had been left alone, if we
Yeah.
hadn't destroyed their society, or, if the world wasn't so global, so early, if we developed transportation later on, would we have more different independent threads of science? It's frustrating to consider what we've lost and fascinating to think about.
Right. I mean, what I was going to say is that even if you look in human cultures, I was actually fascinated to learn that, in Albania they nod their head for no and shake their
Yeah,
head for yes. I mean,
exactly.
like that's something that you think that is the same everywhere, but no,
Hmm.
that's not the case. And
Hmm.
when you count, you say 1, 2, 3, 4, 5 on your fingers, and it seems logical that you will count six like this, but in China they do something like this, right? And then they have this another hand gesture for seven. And I met this Chinese student, at a conference, and I knew about this earlier, but then he confirmed it. He said that, yeah, we do this for six and then another gesture for seven. So again, something that seems natural to you is not, true for other human beings as well. So what you were saying is that, what you were saying, some minutes ago was that if there were like multiple Earths, people may not do science on them in the same way. That thing don't you think that thing can be, true in the future? For example, if we, make it to the stars, right, in the future, and like humanity is like scattered on a lot of planets, and possibly in other galaxies, right? I don't think that we'll be able to communicate with each other very well if we are in multiple galaxies. And then if we are, in multiple galaxies, in the far far future, after that, how the science will be done? Don't you think that even that may be different, although the origin was
Absolutely.
same, right?
Absolutely. And I think that touches on a really interesting and deep point, which is the process of science itself, not just the results, but the process, right? And what we call science is fairly recent, a few hundred years old, but it's not, as people often are told, this moment where like Galileo and Francis Bacon were like, oh, we should confront our ideas with experiments and developed empiricism in some afternoon. It's a more of a gradual development of these ideas. And people, even the Greeks, though we don't often say it, were doing experiments. And so the process of science itself is changing. And we didn't even have jobs you would call a scientist until like the 1800s, and the divisions of the fields. And so I think it's very likely that in 100 years, in 500 years, in 1,000 years, the way humans do science is quite different. And we will look back and be like, oh, ha ha ha, those guys were so primitive. They didn't even consider this new direction or this new tool, this thing we added to science, which makes it so much more powerful. And so I think, yeah, it's very likely that the way we do science in the future will be different. And as you say, if humanity fractures and the distances between cultures is large compared to the speed of light and at times the age of a human, then it's likely that culture fractures and that science goes in different directions. Absolutely. So in that future, we're sort of like our own aliens. We can recover this sort of like independent directions to explore the universe. Boy, I wish I would live long enough to see that. It'd be fascinating.
Right, right. I wish that at that time, even if human beings cannot travel to one galaxy to another, I hope that we can travel, send information somehow, like some
Mm.
wormhole or something like that, because I want to know. For it may become that it may become a thing that okay, that galaxy specializes in this thing, right? They study this thing very well, right? And this galaxy, it may be like an East Coast West Coast thing that okay, on West Coast they study this thing very well, and then East Coast they study this thing very well.
You want to work on black holes, you got to go to Andromeda University.
Yeah,
That's just the best
exactly.
place for it.
I would love that. And even before that, when we are in the Milky Way galaxy, it may become a thing that
Uh-huh.
okay, that planet does it very well, and that the
Mm.
people on that planet specialize on this thing very well. Probably it can happen that okay, that planet is close to this astrophysical object, so that therefore it's better
Mm,
to do
yeah,
that kind of astronomy because
yeah,
their
it could be.
location is very good for this. So yeah, that will be great. Another thing that I was wondering is that I was reading this book. Probably you have seen this book called Talking to Strangers by Malcolm
Hmm.
Gladwell.
Hmm.
That book, has a lot of studies about this thing that how difficult sometimes it is to talk to people who are strangers and mostly those people who are not from your culture. For example, there was this study that two researchers went to some island in Pacific, and there, in that island, people were perplexed by what anger is. So they show them, an angry face, and almost all of them said that this angry face is actually a face which is scared. They couldn't see what anger is actually. They thought that this person is scared actually. So even when it comes to human beings, the communication can be, a bit of a challenge because sometimes the expressions or some other, like the demeanor that we take for a person that we take for granted may
Yeah.
not be communicating what they're actually communicating. So what what are your thoughts about talking to aliens that may not have the same bodies as us? Because a lot of communication is done by like by the body language. So, what kind of problems do you think that we can have apart from the language itself, of course,
Yeah.
when we talk to aliens? Do you think that would it even be possible for us to talk to aliens if they show up on Earth?
Well, I think that's a really wise question because it highlights that we are probably unable to imagine what things will be difficult. As you say, you go around the world and you are shocked by things that we don't have in common that you thought were fundamental to the way the humanity existed. As a young person traveling around the world, I was like surprised. Oh my gosh, people eat weird, spicy food for breakfast. It had never even occurred to me that you could eat like, fish soup for breakfast. And now, of course, it seems obvious, but I think often we're blinded by the boxes that we're in because of our experience, and we can't even imagine other ideas. And so, I mean, the short answer is I have no idea, and I don't think anybody does because we can't imagine what assumptions we're making. And that's really the spirit of this project, this book, is to try our best to push the boundaries and to imagine, like, how are we making assumptions? What about our process of science is actually human and we imagine that it's universal? But I think we will have a lot of difficulties talking to aliens. I mean, I think, imagine number one, like, who are they going to send? Even if they have the same goal to share knowledge about the universe, we have a culture of science and a community of people we call physicists. That's very cultural. Like, what if they send us their priests or their bureaucrats or their, some subset of society that does this and that and the other? Like, we might not even know like how to make those connections. Not to mention like sitting down using pen and paper and writing Lagrangians on the board. And I'm very glad to hear your skepticism because I find that in physics, a lot of people are very confident that physics is done the same way around the galaxy, and that they'll show up and we'll spend an hour with the linguists, and then we're going to be at the chalkboard together writing down Lagrangians. That there's this, and when I talk to people at CERN, for example, and you ask them questions like, do you think the Higgs boson is real, or do you think it's part of our model for describing the universe? They don't take a moment to think about it. 99.99% of them are like, oh, of course it's real. It's a real thing. Aliens would find the Higgs also, obviously. But, I think there are important philosophical questions there about like
Right.
whether this is part of our language or whether this is part of the universe. And I think most
Mhm.
people in physics don't give these things a second thought. So I'm glad to
I
hear that
mean,
you've thought deeply about them.
well, when you say the way the physics is done, I do understand that it may happen that they may not be able to write, for example.
Hmm.
They may not use like the same. I will be very surprised if they use the same symbols. I mean,
Oh, of course not.
that's
Yeah.
not going to happen, of course. So, but I will be very surprised if physics is different. Physics
Mm,
itself is different. For example, we can I mean you know more than this about me, of course, because you are an experimental physicist. That we have like data from like far reaches of our galaxy,
mm,
and we can make sense of that. Not all of it, of course. For example, we don't understand what cosmic rays
sure.
are made up of. I mean, how are they produced? But a lot of data does make sense given our physics.
Mhm.
So I would be very surprised, and of course that's surprised and excited if
Yeah.
physics is different in different
Mhm.
places in the universe. That will be a very, very surprising thing to me. I
But
mean, so
let's dig into why that would be surprising because there's a
yeah,
philosophical assumption there. You say
mhm,
there's data, we have a theory which does a great job of explaining almost all of it,
right.
and there's you add one more assumption which is if you have a theory that explains the data, it must be the right answer. It must be what's really happening.
So there
But
is something called underdetermination of theory, right?
exactly.
There may be another theory that describes the same things, that we have seen. Um, but again, it may be the case that our theory is wrong, right?
Hmm.
That's possible. What I'm trying to say is that I will be surprised if physics is different. It may be the case that the physics that we have is not entirely correct,
Yeah.
but the correct theory should be correct everywhere. That's what I'm trying to say.
It could be, but it's also possible that there are
Mhm.
two correct explanations, two conceptually different frameworks that tell
Yeah.
different stories about what's happening behind the scenes and give the same predictions for all experiments. This is a hot
Yes.
topic in philosophical circles. Like,
Oh, yeah.
is
Yeah.
there a unique explanation? And you might think, well, of course, there's something happening, right? Something is happening, and either this explanation or that explanation is correct. But we don't know that, right? That's a philosophical claim. It's an assumption. It's what we would
Right.
love to believe, but we don't know that. And we can see that immediately just in like simple examples. Like you take a bunch of data, you try to describe it with your theory, right? And there's always another curve you could draw between your data points, right? There's an infinite number of
Sure.
theories, as you say.
Sure.
And so the philosophical question is like, if two theories give the same predictions, is it possible for them to be conceptually different, or is it just two theories wearing different clothes, right? And that's exactly the battleground in philosophy right now. Some people
So
arguing like they must be the same if they give the same predictions, and some people saying they don't have to be.
no, no,
But
they
it's
don't have
not
to.
clear, right? We can't
Right.
confidently say that if we have a theory that works perfectly, even in the far future, we have quantum gravity and a theory of everything, blah, 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 and it describes all experiments. We can't confidently say that there isn't another theory out there that also does the same thing.
So, okay, if we are talking about philosophy, so let's go there just a bit. So,
Yeah.
when you say that two theories that give the same predictions, they are the same when it comes to epistemology, right? So, the predictions that you're trying to get, you can get the same predictions. But when I say the correct theory, I think that the correct theory should come with the correct ontology. And
Mm.
I would be surprised if there are two ontologies, right? So very, very
So would
surprised if
I.
there are two
So would I.
ontologies.
But it doesn't mean that it can't happen, right?
Of course. But I would be very, 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 very surprised if there are two ontologies, which,
Why?
I
Let's
mean,
dig into that. Why would you be surprised?
well, because the thing is that, first of all, if you just, write down the space of all possibilities, I think just because of statistical arguments, it seems to be the case that two ontologies may be, a very, very unlikely because and another thing is that if there are two ontologies, you have to make sense of the world based on the two ontologies. So one ontology should give you the right predictions, but the other ontology should also give you the right predictions, right?
Mhm.
But then the question is that do these two ontologies interact with each other, and if they do interact with each other, are they two ontologies or are they part of a single ontology? And another answer that I can give you is Occam's razor. I mean, Occam's razor itself says that okay, simplest possibility should be the right possibility, but
Yeah.
but these are some of the reasons. But again, it's not impossible, but it's very, very, I mean, it's very surprising. I mean, if it happens, I would be very, very surprised if there are two ontologies of the world. It may happen so that there is nothing fundamental. So if we do have some reasons to believe, although those reasons are like far-fetched, that the concept of a fundamental thing
Mm.
may be flawed. For example, there is this duality called olive Montanan duality. Although it requires supersymmetry, so it's not based in reality yet. But olive Montanan duality says that uh, what seems fundamental, like a particle, can become something composite in a different duality frame. But those two descriptions should be equivalent because they're just dual to each other. So it can happen that, okay, what is fundamental is a meaningless question, but having two ontologies is surprising, still surprising for
Yeah.
me.
Yeah, it
Uh,
would be very surprising. I agree. But that's exactly why we should be open to it, right? Because
mhm,
we are, I think, biased against the things that are uncomfortable or that, make us question the foundations. But that's
right.
exactly the most interesting thing about meeting aliens is learning about where we have made assumptions that have blinded us
Mm,
to other directions. Um, and it would be very uncomfortable if there were two ontologies, because then, you have a hard question like, well, what's really happening? Is anything really happening?
right.
Does the universe follow laws? And like, if you want to get philosophical about it, like, what is the justification for the whole project of physics? Is an assumption that the universe follows laws and we can discover them by doing experiments, right? How do we know the
Mhm,
universe follows laws? Well, it seems to work so far. And so, and it works
yeah.
very reliably, and my phone works the same way every day. And so probably we can put that to bed. But, if you push it, there are areas of experimental physics that we can't calculate the predictions for. They're just too complicated. And so,
Mhm,
how do we verify that things really are following laws when systems are super duper chaotic? We can't. And of course, there's a branch of philosophy that argues that there are no laws, that like in the dark places where we can't calculate beyond our ability to predict or to even measure precisely, that the universe, Nancy Cartwright says, what happens happens by hap. She wrote this book called How the Laws of Physics Lie. And like that is very hard to swallow, the idea that the universe doesn't follow some laws, that there isn't some rule for determining what happens in the
right.
future. But just because it's hard to swallow doesn't mean it's not real, right?
Sure, but again, if the argument is that we can't do calculations for those complex systems, that's like something of the gaps argument. I don't know what something is.
Hmm.
It's not God of the gaps, of course, but it's something of the gaps argument. I mean, what if we can do it in the future? I mean, there were some calculations that we couldn't do in the past, but we can do them now. So,
But no
um,
matter how powerful your
mm,
calculational machinery, there's always going to be something there. There will always be a gap.
sure,
That's the power of that
yeah,
argument,
that's the
right?
thing.
Yeah.
But the thing is that again, that's just an evolving thing. I mean, if your argument relies on that gap only, that gap is going to shrink over time, of course. So that's not a
But
good
if you can
argument.
argue that the gap will always exist, even if it shrinks, that there is always some
I'm
element
not.
of it which
I'm
is
not sure if
preserved.
I'm not sure if it will always exist. I mean, it
Hmm.
may be the case in the future that, for example, you can predict a behavior of a human being using standard model. I mean, you never know, right? I mean, we just you just need a lots of computational power, and well, it may be chaotic, but I'm not sure about that. I'm just thinking out loud now.
Hmm.
One thing that wanted to discuss is this. So let's take something like general relativity, right?
Okay.
Now, general relativity, we do know that general relativity is correct because of astronomical observations and lots and lots of astronomical observations. But if
And
aliens
by
are,
correct, you say, obviously within some boundaries, right? Like
yeah,
we
yeah,
don't know
sure,
that
sure,
it's
sure.
correct inside a black hole or the
It's
universe,
certainly not
etc.
correct.
Yeah.
I work on quantum gravity. It's certainly not
All right.
correct
Good. Yeah.
because
No,
if
I
it
just
is, then
wanted
I'm
to
out of a job,
be
right?
precise about it. Yeah.
Right. Okay.
Okay.
So, but yeah, in within some bounds. The thing is that if aliens are like very, very, very advanced and they have like very high technology,
Yeah.
is it unreasonable to think that they can manipulate astronomical objects? If they can, then what if they are manipulating astronomical objects to fool us and to so that we
That's
get
not-
the wrong data, right?
Oh, I
Yeah, okay,
see.
your theory is correct, sure.
Lead us astray by tweaking
Yeah,
the universe.
right. Again, it will be a very malicious species of aliens, but it's again not impossible if they can do it. What if they can manipulate the stars? What if they can manipulate the
Hmm.
starlight coming
Hmm.
to us? Then they may be, giving us the wrong data, right?
Yeah,
And
I mean, look, the ingredients you need for life and intelligence have been in the universe for a long, long time. It's not
right,
hard to make an argument that you could have an alien civilization that is literally billions of years old if they've managed to survive and not kill themselves and pollute their planet, etc. So billions of years are very hard to fathom, right? Our civilization is so young compared to
Yeah.
that. And so now we're extrapolating from this tiny bit to like, what could we know in a billion years? And I mean, you could basically put anything in that category. Maybe they can invent new galaxies. Maybe they can spawn whole universes. Like in a billion years, like especially because progress is exponential, right?
Yeah.
So, I mean, extrapolation, like the error bars are just
Right.
unfathomably huge. Yeah. But
So
I
it,
think that, there's another question there, which is like, say aliens are very technological. Do they care about the same questions we do? Like, you say maybe they have GR or something like it, but maybe they don't care. Maybe they have developed these tools through some sort of like, trial and error, stumbling through it. Maybe they're not curious about the universe the way that we are. Maybe that's human. And maybe they
Mhm.
don't care about developing compact mathematical models that address their philosophical quandaries. Maybe they just sort of do it. And when they show up with their
Right.
advanced technology, they're like, we don't know what you mean. How does it work? We showed you how to build a warp drive. What else do you want? Right? Whereas what we want is like, yeah, tell us the ontology, what's really happening. But maybe they don't care and they never figured it out.
So what you were saying is that aliens may not have philosophers.
Yeah, and maybe aliens don't have scientists or philosophers. They're just like technological wizards, and they figured this stuff out through trial and error. Like humans were technological long before we were scientific, right? We were
Yep.
like experimenting with leaving your milk outside and developing yogurt and cheese and,
Sure.
developing sharp weapons without understanding the metallurgy and the solid state physics inside of it. So you can
Right.
imagine a universe. I mean, if you're going to go with like, malicious aliens manipulating the
Mm.
universe, then we can also imagine aliens that just never become scientific because they don't have that desire to know, the desire to understand. Just
You,
speculating, but we should be
do
open
you
to
think
these
that
kind of possibilities.
they can become technological before without becoming scientific?
Yeah, absolutely. We were absolutely
How?
humanity was technological.
No, no, but uh, rules of science are used to develop technology. That's what I'm trying to say.
Absolutely. Science is an excellent accelerator, right?
Yeah.
To understand how things work allows you to better explore the possibilities, and you know how to build that next chip and that next, why you should dunk your blade in water or not. It's
Mhm.
certainly an accelerator, but again, it's not absolutely necessary, right? You could be technological without understanding. It would take longer, but aliens have had a lot
Sure.
of time, right? And so I think it may be a cultural thing, just this desire to understand the universe. It's hard to imagine living in this universe and not wanting to know how it works, but that's because we're humans. And if you break out of that box, you strip away all of those assumptions.
I mean, would you call those aliens intelligent if they don't understand? Yeah.
Yeah, it's a great question. I don't know. They could feel love and joy and enjoy music, and develop starships and travel the galaxy and eat delicacies and not care about quantum gravity at all. They
Like
may fail your
seems like a
test for
teenager.
intelligence.
Seems like a
Exactly.
teenager. I mean,
Exactly. What if they're teenagers?
a question that I asked earlier is that do you think that aliens may not have philosophers? And you said that
Yeah.
it's possible. Okay, so philosophy of science is one flavor of philosophy, but most of the philosophy, you know, don't you think that a lot of philosophy is there because we have a fear of death, right? And if aliens don't have a fear of death, then I can understand that, okay, they don't have philosophers at all. But if they have a fear of death, I would be surprised if they don't think about the meaning of life and what happens after death.
Hmm. Wow, that's
Um,
fascinating. I think I disagree with you on the basic premise. I
mhm.
think you can want to understand life and how to live it and what to feel about it without being afraid of death. Like you can embrace death.
It's
You can
possible.
you can
Yeah,
say like, look, life is wonderful and it's interesting, but it should be finite. The way like you go on a
sure.
hike and it's beautiful, but you don't wish that hike was infinitely long, right? You're
Sure.
glad at the
Okay.
end that it's done. And so I don't think that a fear of death is necessary to appreciate life.
I
And
agree.
and yeah,
Okay, but at least you should. I would be surprised if there is an intelligent person out there who doesn't think what is the meaning of life, even if that
yeah.
person is not afraid of death.
Hmm.
Then, if you have intelligent aliens, don't you think that they contemplate about the meaning of life?
Yeah, but again, their intelligence could just be very different from ours, right?
Okay.
There could be a form of intelligence that just doesn't care, it just is. The way that some questions are exciting to you and you just can't imagine not knowing the answers. And for other people, even other physicists, they're like, whatever, I don't care. I mean, I'm struck that even inside experimental particle physics, we have people who
Hmm.
like build detectors and people who operate detectors and people who analyze data and people who just write software. And they all think they're doing the juicy bit. They all think that their piece is the science and everything else is engineering. Like, oh, I build the detector. Some people, whatever, they make it work and write the papers, but like building the detector is the experimental physics. And other people are like, yeah, I'm analyzing the data. I'm doing the real physics. Everybody thinks they're doing the interesting bit and everybody else is just like, the support team. And I'm not saying experimental physicists are all egotists, but it just tells you that like it takes all kinds. And even in humans, we have people who are curious to death about something that other people are really bored by. So there's an
Hmm.
enormous variety of things we're curious about, even among humans. And so aliens, wow, yeah, you got to broaden that picture by a zillion.
Okay. So again, I don't want to give spoilers, but there's another chapter in your book that I want to talk about, and it's about human dating aliens. So, what do you think about that possibility? Do you think that it will be biologically possible, for example, that humans just conceive with aliens?
I mean, I don't want to lead people astray. The point of that analogy in the book was, there could be a lot of aliens out there that are just really weird and don't care about physics or do physics in a way we just can't grok. And that's okay because as long as there's one alien race out there that does physics similar enough to the way we do it, then we can still learn a lot from them. And also, by swiping left on all those other aliens, we can learn something about, who we are and what we care about. When aliens arrive, could we actually have romance between aliens and humans? I do not think I'm qualified to answer that question, but I've watched enough science fiction to know that it's going to be complicated.
Hmm. I mean, do you think that like aliens which are like super advanced, they reproduce like we do? I don't. I will be surprised if they reproduce like we do. It's very inefficient sometimes,
Yeah, it
the
is,
way we
and it's
reproduce.
dangerous. Yeah. No, I think that even humans in enough time are going to develop this technology to make like our current reproductive systems feel kind of squishy.
Hmm.
Artificial wombs don't seem impossible, for
Hmm.
example. And it opens up a huge number of ethical questions that I am just not qualified
Yeah,
to
sure.
answer. But yeah, I think that the way that we reproduce in the future will be very different, and I expect aliens if they're advanced, we'll also have a plethora of ways to solve some of these squishy problems.
Right. But even if we don't talk about reproduction, do you think that aliens dating human beings is a possibility?
Hassan, I'll be the first person to put you on Alien Tinder if that's what you're looking for. Um, I think it's a possibility. I mean, people look, there's always somebody out there who's into whatever it is. And so somebody out there will be like, wow, those aliens are hot, I'm sure.
Yeah, but I think even for that, I mean, we have to solve the problem that we can talk to aliens. So if we can solve that problem, then it's not unlikely that there can be a society where human beings and aliens just live together. I mean,
Hmm.
they may be, for example, they may have different needs from us. So there may be like different alien supermarkets as compared to human supermarkets. But if we can solve the problem, I mean, two problems. One problem is that they're
Hmm.
not hostile to us, and the other problem is that we can talk to them, right? Then, I mean, what is the reason to believe that there can't be a society where human beings and aliens just live together?
Yeah, I think it's impossible to predict what's going to be difficult about that, but it'll be a lot of fun. It'll be super fascinating. Absolutely. And I think that when the aliens arrive, the physicists will have a lot of fun figuring out what's different, and the sociologists will have the most fun, and the linguists and all those folks. It's going to be a lens that we can use to understand the human experience. I think it's going to be fascinating. I can't wait.
Right. I mean, there are some topics that aliens may not even know because those topics are like very human. For example,
Hmm.
a human psychology. That's a topic that is like very human. Do you think that aliens will have like these kind of topics as well, like alien psychology, or do you think that they again they may not care about it at all? because they have different problems to work on.
Yeah. I think that, it'd be difficult to even pinpoint what alien psychology means, that
Mm,
their ways of life and their interactions and their struggles and the questions they have about it are going to come out of their society and their experiences, and those are going to just be so different from ours that it's going to seem all very alien. I think it'd be very hard to match almost anything sort of at that level of culture in our experience to theirs. But it could be very different. It could be very wrong. It could be that our experience is very typical in the universe, and that when aliens show up, they have same struggles and the same ideas, and they like Woody Allen movies because they get it. It could certainly be. I'm trying to think about the denominator and imagining that it's broad, but we just don't know. And it could be that our experience scientifically and personally is very typical in the universe. That's why I'm so desperate to meet them, because that's really the only way to know is what is the breadth of this population. We have one sample from it, which is us. And even just a second sample from that distribution would tell us so much about how broad or how narrow it is.
right. I mean, there have been some like ideas in the past, that didn't work. For example, ether and things like that. Do you think that any of those ideas can actually be true, and aliens will tell us, okay, you had this idea, but you thought that it's wrong, but it's
Hmm.
actually correct.
For sure.
It, I
For
mean, is
sure. I
there
mean,
any
we've
idea in your mind that may be correct?
Yeah, I mean, we've gone down the wrong path before, right?
Hmm.
We people like were deep into ether theories, even after the Michelson-Morley experiment. We'd like to tell the story like they did that experiment and then we moved on from the ether. But if you go back and read the papers, like it took decades before people were like, oh, okay, all right, yeah, we're gonna let go of that idea. And so it takes us a while to correct. And so almost certainly there are ideas we have now that are wrong, that are not going to that are not going to be fruitful. There are interesting questions about, even at the heart of general relativity, like Machian thoughts about, rotating frames that are still sort of unanswered. Also maybe general relativity, the whole project maybe is the wrong direction. Yeah, I like to imagine, what could have happened if we had developed quantum mechanics, 100 years earlier, so that Einstein himself grew up learning quantum mechanics and finding it intuitive and natural. Would he still have developed the classical theory of GR? Is that whole project just due to an accident in the timing? Would he have developed quantum gravity or gone another direction? Who knows? Alternative Earths might tell us, or aliens.
Um, so in your book, are there some like questions that you wanted to address but you couldn't because of the length of the book?
The first draft of the book was twice as long as the
Oh,
draft I ended up publishing,
a lot.
because there's just so much I wanted to talk about, so many different directions and ideas and examples I wanted to think through. But it was a lot of fun, writing all of it as an exploration. And then, editor was very helpful, and a lot of friends reading it, telling me which parts they thought were more or less exciting. But there's a whole chapter I wrote on a question that you raised, which is there even a fundamental explanation of the universe? Because a lot of people imagine that you can avoid some of these issues. Do we see the same emergent phenomena? Do we use the same, mathematical notation by like going all the way down to the fundament and saying, if there is a core element, a foundational layer to the universe, then that's inescapably common. And we have to then eventually find that together. But as you say, we don't know. We don't know that there is a foundational layer to the universe. It could just be all emergent phenomena stacked on top of
Mhm.
each other, right? Um, and there's this very widespread misconception in popular physics that we know the universe has a foundational length scale, and it's the Planck length. And there's this idea out there. I don't know where it came from or who popularized it, but you see it everywhere among the public, that we know the universe has a pixel length. And of course, we don't. It's just the limit of our ability to calculate the place beyond which we can no longer ignore quantum effects in gravity or gravitational effects in quantum
Yeah.
mechanics. And so it's our intellectual horizon. It's not the pixel length of the universe. And as you said earlier, it could be that there is nothing down there. It's just a ladder that goes
Mm,
on forever, in which case we're not guaranteed to find common ground with aliens.
right.
So yeah, I had a
I
whole
mean,
chapter about that the editor was like, maybe move that out.
sure. Yeah. I mean, distances stop making sense before, below that length, but that's it. It's not like a pixel thing. I mean,
Yeah.
space-time is not fundamental itself, I think. But yeah, so, okay, that's one chapter. So, I mean, you said that the initial draft was like twice as long, so you can publish this book in like two parts if you want, right? If
No,
the
I
you
think
have
I, I took out the best bits and saved them for the book, and the other ones weren't quite working because when you're writing, you have ideas for what you want to talk about, and then you get excited about something. Like, ooh, maybe I could get talk about this, and you write it, and then you're like later you come back, you're like, I see why you wanted to talk about that. It's not really for this book. So yeah, there's lots of stuff I wrote which I'd love to include in another book at some point, but maybe
Mhm.
well, it didn't quite work in this book.
I
But
see.
that's
I mean,
that's the
did
joy
you?
of writing is, discovering on the page what you want to talk about.
I don't know if you included this in the initial draft, but did you include the possibility that do aliens have the concept of money, for example? That's an interesting question. I mean, or is everything like it's like a utopia there? Everything is, free for everyone if you just consume as much as you want, but that's it.
Yeah, well, there's a interesting angle there because how we value things shapes how we count things, which shapes how, we do mathematics. And so it's not
Mm,
that hard to make a connection between like the fundamental economy of life and how we think about the universe. And I talked to a zoologist who argues that predation is going to be universal. He said
what is
that
that?
it basically, as long as you have critters moving around, somebody's going to try to take a bite out of somebody else, right? And so you're going to have this sort of competitive economy, just at the biological level, right? Predators and prey, and that will be a common environment out of which we will, have a common sense of, what is valuable and what is not. And there's a lot of links in that chain. I'm not sure the
Hmm.
argument is really robust. But
Right.
you could make an argument that if you have predation and you have common sets of, common economic conditions, essentially, and that eventually you have common sets, concepts of value, and then money is a bit of an abstraction, but, it's not too far to go.
But initially, we discussed this possibility that aliens may not be familiar with the concept of integers. So
Yeah.
how can they make sense of money without integers? I mean, that
Yeah.
will be interesting to see that how can they
hmm
count stuff without knowing what integers are.
No,
Um,
and you're exactly right. And this whole line of argument rests on the concept of having integer people, individuals, which take bites out of each other and eat each other. If instead you're in some sort of like common pool, drawing from resources in common, then you could end up with a very different sort of evolutionary pressure and economics, which could lead you to think very differently about the universe for sure. Yeah.
I mean, if you have like, so correct me if I'm wrong, but are you saying that there may be like a collective intelligence, which is like a single individual, but not like multiple individuals which are different from each other? So is that what you're saying?
Well, I think there could be lots of things. There could be some single collective individual, or you could have something where there are individuals, but the boundaries between them are fuzzier, right? Where
Hmm.
it's not so clear, like this is Bob and that's Sally. The way, for example, like an octopus
Like a
has,
Siamese twins.
yeah, yeah,
Okay.
Siamese twins or octopi, they have like not just a central nervous system, but they have like little mini brains in each leg that makes decisions. So, what
Hmm.
is it like to be an octopus? Is there something it's like to be one leg of an octopus and to disagree with the core mind? Is it one holistic consciousness that fills the whole body? Like, we don't know. We probably can never know. But I think there's lots of different ways to be aware in this universe, even without crisp distinctions between people.
Right. I mean, if you can't make sense of an individual, then don't you think that a lot of theories of economics and even like politics break down because
Yeah.
they hinge on the fact that you have
hmm
individuals.
hmm
Um, I mean, I don't know if somebody has worked on this direction that, okay, how to make sense of like economics and politics without individuals. I mean, that will be a very interesting problem. I don't know if people have worked on it. Okay, so I have some questions from the people, and then we can, finish this. So, one question is that do you think that it might be arbitrary the amount of direct dimensions other forms of life might be able to experience? Could they be able to solve, oh, sorry, could they be able to observe dimensions we are unable to?
Well, that's a fun, really fun idea. I think if they're made out of the same matter that we're made out of, their standard model, then they're going to have similar experiences to us, which is that most particles move as if they are in three dimensions. And gravity operates as if it works in three dimensions. The loopholes there are if they're microscopic and if there are very small extra dimensions that evade our ability to see them, it's possible they could move in those additional dimensions. So we haven't ruled out extra
Mhm.
dimensions, on the microscopic scale. And so it's certainly possible aliens are sensitive to those or, can move through those, but they would have to be pretty small. Yeah.
I see. So the next question is that do you think that the aliens may be made of dark matter?
I love that idea because, we tend to think of dark matter monolithically, like, is it one
Mm,
particle? But, the standard model sector is very rich. No reason
mhm,
to think the dark matter sector isn't equally as rich or more, since it's more of the
mhm,
universe. And so it certainly could be that a lot of our conceptions about dark matter apply to the bulk of it, but there could be like, say imagine 1% of dark matter is something more complicated. That lets you avoid a lot of the self-interaction bounds, et cetera, and be consistent with current experiments. And that's plenty of matter to form complex life. So yeah, I think it's certainly possible that the dark sector has complex interactions enough to make dark biology and dark aliens. I don't think it's ruled out.
What do you think of the idea? So the next question is that what do you think of the idea that aliens may be made of antimatter and they can't exist for long in this world because they annihilate?
Well, I think it's possible that there are regions of the galaxy out there that are antimatter dominated instead of matter
Mm,
dominated. We would have seen that if it was pretty close. We looked for like annihilation between, galactic winds at boundaries between matter and antimatter regions and not seen them. So we have pretty good limits that the universe in our neighborhood is matter dominated, but distant regions could be antimatter dominated. And so, yeah, I wish those aliens careful to be careful as they traverse the universe and enter into the matter-dominated region. It's a cool idea for a science fiction story. How
sure.
maybe we're the only matter critters in the universe, and so we're isolated for that reason. That's a cool explanation for the Fermi paradox.
Right, I see. So the next question is a fun one. It says that what physics question do you want me to ask to an alien when I'm abducted the next time?
What physics question to ask the aliens? Yeah, I mean, essentially, that's the premise of the whole book is like, if you got to speak to an oracle, a super advanced race, what would you want to know? And for me, and probably for you, it's about the fundamental nature of the universe.
Mhm.
And so I've dedicated my whole life to answering the question, like, what is the universe made out of? What are its fundamental bits, if there are any? And so I would love to know what aliens have learned about what is the fundamental nature of matter and energy.
So I think this is the last question. What uh, given all I mean this is like a cliche question but since okay let's take it anyway. So the question is that given all the alien sightings that people have witnessed, do you think that there is strong evidence that they have visited us?
No, I don't think there's compelling evidence of
I agree.
aliens. All of those sightings are low information zone pictures, first person accounts. Fascinating. I mean, I wish aliens would visit, but I don't
Mhm.
find any of that evidence compelling.
Have you come across, most probably you have because it was near California where you live. So have you come across the USS Nimitz encounter?
Yeah, absolutely. And that's like the Tic Tac video and the Go
Yeah,
Fast. Yeah. But the folks have analyzed those. Mick West and Metabunk and people, there are prosaic explanations for
right.
those videos.
I think
Um,
the videos itself are not that, compelling, but the behavior of their seniors was a bit compelling. That
mm,
they just came in and they made them sign something that, okay, you can't disclose this thing. That's a bit. shady, I would say, at least. Why did they have to do it? That I don't understand. The
Yeah.
videos themselves are that's not an evidence, of course.
Yeah. No, there's lots of weird behavior in various levels of the government. I actually got a phone call because of my podcast from a
Mm-hmm.
U.S. congressperson who had been at a briefing and he had questions about what he had seen. And is this physically possible? Is that physically possible? So that was a fun conversation to
That's
have,
good that they're calling physicists because,
right?
yeah, I mean, it seems to be the case that they have never talked to a physicist sometimes. I mean, there was this, most probably you know this, that there, so this whistleblower that testified in front of Congress, I think last year or probably 2 years ago, 2 years ago, I think. He literally used ADS-CFT to
Hmm.
justify,
Hmm.
aliens going through the higher dimensions. So, I mean, if there was any person on the Congress who was familiar with the physics of ADS-CFT, that person could have shut him up, but
Yeah.
no, it didn't happen.
Hmm.
Okay, so my questions are over. Thank you so much for your time. And so before you go, can you tell us that when will this book be available for pre-order? Will this be available for pre-order
Yeah,
before it
so
comes?
the book is available now for pre-order. Go to the
Okay.
website aliensspeakphysics.com. You can get it there. The book is coming out November 4th in the US, so please check it out if it sounds like something you'd be interested in. I'm also the host of a podcast, Daniel and Kelly's Extraordinary Universe, where we often talk about
Mhm.
aliens and physics and all sorts of other fun stuff. Thanks very much for having me on today.
Is there a reason why you have, put the launch date of the book on the same day as the election in New York?
That's entirely up to the publisher.
Okay, I see. Okay, thank you so much for your time, and
All right.
I'll talk to you later soon.
Thank you.
So if you like this video, give it a thumbs up and consider subscribing, and the YouTube algorithm thinks that you will also like this video.